Okay, are we good? We could start?
Let's get started.
Okay, great. So, good morning, everyone. Hope everyone is excited as I am to begin this day, another great day at the OCP. My name is Eli Karpilovsky. I'm part of the core switching group at Broadcom, and I'm responsible for the software. Now, I didn't plan to talk about this to begin with what I'm about to say, but I'm very excited to see all of these familiar faces in the crowd here and the people that's sitting here today, because for me, it's not an end-to-end journey, but it's definitely a recognition of a successful journey. I've been in the open communities for the last 10 years, from OpenStack to network OSs. And at the end of the day, you cannot ignore what is a very successful open source project. And that's what SONiC is. And I think we all need to recognize it at this time and take a minute to applaud ourselves for the great achievement of what we have done so far and where we're heading. I think it's not trivial. A lot of people tried it, a lot of community tried this, but SONiC is the de facto open source project for network OS. So today I'm going to talk a little bit about things like instrumentation and telemetry and advanced telemetry, and why we believe at Broadcom that those type of capabilities are essential for making those hyperscalers or cloud providers more efficient in general, and also, more importantly, in SONiC. So the three trends I'm going to just quickly review is obviously network operators are asking to increase visibility and control into the cloud. There's a need for a unified language and interface for controlling hybrid clouds. And of course, the last one, which is the one we're talking about today here, is open networks and tooling focused on network analytics. So once you open up the network OS, the next logical step is to customize and build tools that allow you to really extract the value of your network and to really optimize the workloads that you are trying to run. And for that, you need advanced telemetry. So there's a lot of features, a lot of capabilities. You're probably going to hear it in the next hour, 2 hours, or day. Every vendor has its own capability that we all believe is unique to make your life, or as a consumers, as end users, easier. But at the end of the day, what makes all of this available, the time to market that we can now accelerate, is SONiC. And I want all of us to recognize that. So what is Broadview? Broadview, in a nutshell, is an instrumentation suite. And what it does, it it enables control loop in a platform-agnostic manner. This suite is defined as standard telemetry API that application can invoke in a platform and device-agnostic manner. It is very scalable, and I can tell you that scalability is a key requirement when it comes to some of the large hyperscalers out there. When I'm going to talk about it later on, when I'm going to talk about IFA and why we came up with IFA to begin with. But it's all about scalability. The third bullet here is really about taking unique capabilities from Trident, especially for Broadcom, from Trident to Trident 2 to Trident 3 to Tomahawk to now Jericho 2. I'm going to talk at the end. There's few demos at the Microsoft booth. There's few demos at other partners of ours that showcase some of those capabilities in their specific environment over SONiC. And lastly, faster time to market. Traditionally, and I think all of my friends at Mellanox and Barefoot will agree, we as a cheap vendors are coming up with some of the most advanced features that we can think of, talking directly with end customers and our OEMs and ODMs. But in reality, what makes that feature to be available at the end is if the OEM or if the solution vendor choose to use that feature. What this Broadview agent did, or still doing, and now together with SONiC actually doing it much better, is giving you the option as an end customer to really choose if this feature is required or not, and then go back to your OEM or your solution provider and ask him if he can deploy it. So that freedom to choose from a very long list of capabilities is now in your hand as users. And that's the revolution that we bring with either SONiC, SCI, or Broadview ecosystem. I'm going to go quickly on this one. The ecosystem started about 4 years ago when we launched Tomahawk device. That was the first device to put the Broadview agent reference on top. Since then, we added a lot more ASICs and platforms. Next slide will show you a little bit about the ecosystem. We're targeting different segments from data center to service providers to enterprise and many use cases. We'll touch upon some of the use cases that we are working on. This is a slide that just go over some of the partners that we've been working for the last 4 or 5 years, ODMs, OEMs, system integrators, orchestration solution like Apstra that if you have time, you could stop by at their booth and take a look at their demo. And a lot more is joining. So either because of SONiC or just because they understand the value, definitely the Broadview ecosystem is growing tremendously in the last few years. And we now have dozens of partners that supporting this as a unified standard API. And that's all that really means. It's the ability to expose the API to the application in a unified manner. No matter what platform you have underneath, no matter what ASIC you have underneath, the API remains the same. Your ability as an application vendor to really write one time, invoke the data, consume the data, and present the data is the same across the industry, which I think it's very much aligned with what the SCI community is trying to do, what the SONiC community is trying to do. Now a little bit about SONiC. I think the revolution of merchant silicon and open source software for building cloud scale deployment is on the way. Like I said before, there's no doubt about it. SONiC, which is now powering some of the world's largest data center and network in the world, has a footprint that is growing rapidly. It is a manifestation of open source software vision, truly. We at Broadcom really believe that the combination of the silicon coupled with the serviceability and the high reliability of SCI and SONiC will further accelerate the adoption of the cloud scale networking. And I think that's really the main issue here, right? You know, I've been involved in OpenStack community since day one. I witnessed some of the end customers that were burned, you know, trying to just take some of those raw implementation and use them. And I think what SONiC really brings into the picture with the close help of all the vendors, by the way, is really that quality of their implementation. That's what makes SONiC that unique. And we've been in this community since the early days. I think one could agree that back in 2014, when even before the first initial or original SCI spec, we helped kind of defining that first SCI spec. And since then, we now have over 20 platforms that we support with SCI. And it's a growing list for 2019. We're partnering with Microsoft and a broad community to maintain the tremendous progress towards delivering this cloud optimal networking solution. And of course, one key element of building this advanced data center networks is enabling deep telemetry. So what you see here in the list is just few examples of how a SONiC data center will look like. And then imagine that in each of those top of racks, leaf spines, there is a Broadview agent enabled. And once it's enabled, it's becoming aware. And then through SONiC, either through the CLI or some partners that are developing GUI or other automation tools around it, you can now invoke data directly. So today, the focus of this, the next 2-3 minutes, I'm just going to go quickly and explain the first bullet, which is the InBand Telemetry. And hopefully, we'll do a good job in explaining why we believe InBand Telemetry is critical for SONiC. So in a traditional network monitoring, an application pulls a switch host CPU to gather aggregated telemetry probably every few seconds or even few minutes. What the first InBand telemetry protocol did was to enable packet-level telemetry by having packet processing details added to the data plan packet, right? This is without consuming any host CPU resources. Each of the network nodes will add its own metadata of matrices as the packet traverse through the network. And that means that the last node in the network will be able to extract cumulative metadata added by all of the hops as the packet went through. It then generates and sends reports to monitoring application, aggregate information through a collector, and then there's a monitoring tool that do the deep analytic on it. And by that, you kind of innovate a lot of new use cases. The next stage is, so as we looked at that specific InBand telemetry capability, we immediately recognized that there's some improvement needs to be done in order to actually take that capability, which we believe is very important, and scale it. And that is why we came up with the commercial grade hyperscale solution we called InBand Flow Analyzer. I could tell you, and I could proudly tell you, that it is being deployed on a tier 1 cloud and supporting with devices like Trident 3 X7, which is our latest Trident 3, either at the top of rack or Tomahawk 2 at the spine. It happens now on OEMs and ODM boxes, so across all of the platforms you could think of. And we are working very closely with the industry-leading thought leaders to standardize this IFA protocol at the IETF. Now, using IFA, it becomes a lot easier to analyze when a packet is entering and exiting the network. Better understand what the path that the packet is taking, how long the packet spends at each hop, and which switches experience congestion, including microbursts. That's actually the demo that we now have at the Microsoft booth. We all know that disaggregation is rapidly changing the network at the ecosystem, and it's really a key enabler here to successfully deploy solution with this new paradigm using IFA, because it gives you the ability to better analyze and optimize your network using this capability. We proudly present or announce that this availability of InBand Flow Analyzer is now part of SI and already integrated into SONiC. This is the example I was referring to. As I mentioned before, we have live demos of this capability at the Apstera and Microsoft booth. And we would like to thank our partners Microsoft, Apstera, and Quanta for giving their support in these demos. We're committed to make this solution available in our next generation silicons. And we want to encourage, I'm not going to have a specific slide talking about next step. I'm just going to say we encourage you to join this community and leverage both IFA and other features that we're adding to SI through the TEM 2.0 spec and SONiC, and make those capabilities part of SONiC. I'm going to finish with one last slide. And in this slide, I'm just going to talk a little bit about the ecosystem, like I started with. So left to right, up to down, innovation across the entire ecosystem, from OpenStack to Splunk to, of course, SONiC, Ganglia, and other tools, giving us the ability to really use and leverage all of the silicon capabilities underneath at the application level. We have over 100 contributors across the ecosystem with real live deployments. We're enabling a lot of more advanced capabilities, and we're now enabling inside SONiC ecosystem those capabilities through SI TAM 2.0. So I'm just going to spend 1 second about this, and this is where I'm going to end. The agent offers a Apache 2.0 REST API. Everyone can use that. Now, the next step is taking that, making it adjust to the SI. We're already doing this through the SI and SONiC community, through the TEM 2.0 spec. And the final stage for us, to make that same agent that is flexible across so many OEMs and ODM platforms, is that plugin that we just recently contributed that allows you to invoke the data directly from SONiC through the Redis database. With that, I would like to thank you again for your great support in the SONiC community. Have a great day. Thank you.